arithmetic series. And a series is talking about the sum of the values in a sequence. Okay, so this is kind of your sequence formula. And as long as you know what each of the variables in the sequence formulas refer to, you can essentially deal with any of the sum or the series formulas because they use the exact same letter. So like you said, A is first term. D is the difference in each term. So what it's changing by. Spell that right. There you go. And n. N is the number term we're referring to. So number of term. So if we're talking about the 10th term, n would be 10. If we're talking about the first term, n would be 1. Okay, so that's what they're referring to with those letters. So let's look at our series formulas. They've given you 2 of them. And the reason they say s to the n is the sum of the series to whatever nth number. So technically a sequence could be infinite. It could just keep going and going and going, right? In order to sum it, and there is sums of infinite series, but we're going to talk about where it actually ends at a value, okay? So they've told you that depending on the number there is, so say we're talking about the first 10, would be 10 divided by 2, so that's the 10th term. And then we take 2 times it by the first value, and then we add that to, it's our 10th term again, 10 minus 1 times d. So kind of similar to what we have up here. We're just kind of throwing a 2 in front and then multiplying by n over 2. Very similar to our sequence formula. The other way they look at it is if you know the very first term, the value of it, and the value of the very last term, okay, I don't know, for some reason, let's say they're 1 in 100, okay, we divide by 2 and then multiply by the number of terms. So if there's 50 terms in that, you multiply by 50 or 10 or whatever it is, okay? This one can be simple if you know the values of everything, okay? So let's take a look. Our question is the first 50 odd numbers. Okay, so odd numbers, hopefully we know them. We go 1, 3, 5, 7, well, I almost forgot 9, and then they go on. And we need to figure it out to the 50th term here. Okay, so this could be somewhat difficult to find out what the last one is. Now, luckily, in the question they were given, they told us what the last term is, but we can kind of deduce what that is going to be. Okay, so if the first term, okay, so we'll call this T1 is 1, okay, T2 is 3, T3 is 5. If you're noticing what's happening in T4, okay, the number of terms is going up quite quickly. T5. Okay, and at T5 we're at 9. So it's almost like it's on. Oh, I drew ones that fell away here. T4, T6 will be 11, right? Okay, so there is a relationship here, and if I multiply the term number times 2 and then subtract 1, it'll give me the value. Okay, so what I'm saying is I go 2 times 2 gives me 4, and subtract 1 is 3. 5 times 2 is 10, subtract 1 is 9. Okay, so I kind of found my own little formula within there, and you could have built one using this, but it wouldn't be exactly what we're looking for. Anyways, since we're looking for the 50th, okay, and I just wanted to do this, 50th, we times it by 2, which gives us 100, and we subtract 1. Our last term is going to be 99, okay? And they actually gave that to us in the question. I just wanted to show you how you maybe go about doing that. So, 99 is our last value, which means we can use either of these. We need to define our variables. So what is the very first term in this? What is our A value?
1.
1, perfect, okay. And what is the D value? What is the difference? What's it changing by every time?
3. I think so.
Take a look again.
3, 2, yeah.
Yeah, we're going up by 2 every time. So we're going up by positive 2 every single time. The N, okay, so the N is the number term. Do you know which number term they're referring to here?
50.
Yeah, 50, that's right. They're talking about, this is our number term. They're talking about 50 of them. So our N is 50 in this case. So, according to our first sum of series, so sum of 50, okay, and we'll kind of scroll up and down a little as we do this, is N over 2. So we know that N again is 50. So we have 50 over 2 multiplied by 2 times A. A is 1 in this case, plus N minus 1, which is 50 minus 1. Times D, which is 2. And let's just double check that we did that correctly. And over 2, 2a, go up. Yeah, okay, great. So now it's just simply working this stuff out. 50 divided by 2 is 25. 2 times 1 is 2. 50 minus 1 is 49 times 2 is going to be 98. Okay, so 98. You can just plug in your calculator if you're unsure. 2 times plus 98 is 100. Times 25 is 2,500. I did that kind of quickly, but you could follow with your calculator.
Makes sense, yeah.
Let's try the other sum. The other sum, as at 50 again, they said we take our n value and we're going to multiply. So our n value was 50 multiplied by the very first term. So T1, which was 1, plus T50. Okay, so remember it was T1, T50. What was the last term? We figured
99.
it out. That's right. It was 99. So we'll write that in, 99. And in this formula, we add them and then divide it by 2. So we have 50. This will become 100 divided by 2, which is 50. And we have 50 by 50, which if you put in your calculator will be 2,500. Okay. And here's a simple example of an arithmetic series.